In this video, I'll explain the concept of functions. So in the last video, I had already explained what a relation is. If you have not watched the videos on relations, then please go through those videos. I had shared the link in the description box. Now let us define what a function is. A relation R from A to B is said to be a function if every element of A is associated with unique element of B, which is denoted as F. Means a function is also a kind of relation, but with the stronger conditions. We are implementing few more conditions to make it as a function. The conditions are every element of the set A is to be associated with unique element of the set B. So that every element condition and unique element condition are the extra conditions which are to be imposed on a relation to make it as a function. And we denote that function as F. Take some examples, arrow diagram examples. I have two sets A and B, 1, 2, 3, and B having the elements 4 and 5. I'll take up the function f1, name of the function, under which 1 is related to 4, 2 is related to 5, and 3 is related to 5. Now look at the requirements of function. Every element of A, the first set, B is the second set. Every element of the set A is having association. That condition is satisfied. Now the second condition is every element should have the unique association. 1 goes to only 4, 2 goes to only 5, 3 goes to only 5. Therefore, yes, this is a function because both conditions are satisfied. 2 should not go to more than one element at a time, then the uniqueness will not be satisfied. But 2 goes to only 5, 3 goes to only 5. Two elements may go to the same element. That is not the violation of the second condition. The one particular element should go to only one element at a time. So that is what the requirement. That is satisfied in the first example. So it is a function. Take up the second example. 1 goes to 4, 1 goes to 5, 2 goes to 5. Here, both the conditions are violated. The first condition is every element, 3 is not having any association. And the second condition is every element should be associated with unique element. Now, 1 is not associated with the unique element because 1 goes to 4 at a time and 1 goes to 5 also. 4 is not equal to 5. They are not the unique images of the element 1. They are different images. Hence, both the conditions are violated. It is not a function. Take up the third example, that is 1 goes to 4, 2 goes to 4, and 3 goes to 4. Every element is having the association, first condition satisfied, and every element is having the unique association. 1 is having only one association, 2 is having only one association, 3 is having only one association. All elements may have the same association, not a problem. We are not saying that in the definition all the elements should not have the same association. Can have the same association, but the requirement is all the elements should have the unique association. Unique in the sense one element should be mapped to only one element at a time. It should not be mapped to more than one element. In case if it is mapped, then the uniqueness fails. Take up the last example here. 1 goes to 4, 2 is mapped to 5. The first condition is violated. 3 is not having the any association. Every element should have the association. Therefore, this is not function. This is a function, and this is not a function. So these are some illustrations to support the definition of a function. Now, what a function does is in simple words, general words, that is mathematical definition, every element of the set A is mapped to some element of the set B. That is, then the meaning of this is F is taking an element X to an element Y. So f takes x to y, then that y can be written as f of x. So this y is called as image and this x is called as a pre-image. X is the pre-image of y and y is the image of x. These are the terminologies which we use in functions. And if f is a function from A to B, the first set is called as domain and the second set is called as codomain. The elements which are all having the associations are called as range set. Range in the sense the all the images. Image set is called as the range set. So in simple words, the function can be treated like a machine. Machine takes some values as inputs and it produces some outputs, and the name of the machine is denoted as f. The values which we can give as inputs are called as domain of the function. The values which it will produce as outputs is called as range of the function. So let us illustrate this using few examples. Now consider root x. The function is f of x is equal to root x. So I can input only non-negative reals as in input values, x values for this function, because if I input -1, -2, these are all negative values. We can't find out the negative value of a square root. You can check with the calculator. If you, in the calculator, if you give square root of -2, it will throw an error, mathematical error, because it is not in its domain. Domain in the sense the possible values of x you can give for that function, then only it will produce output. For all values of x, a few functions won't produce output. You have to search which values of x are valid to produce the output. Here only non-negative, non-negative in the sense positive and 0 can be given as value of x, then only it produces the output. So output also all non-negative real numbers. You won't get square root of any number as a negative number. So that is what the meaning of a domain of the function. Domain means it is the value of x at which the function is defined. Range means all the possible outputs which we will get after substituting the value of x into the function. So here domain of the function is all positive reals including 0. Range of the function is also positive reals including 0. Now look at the graph of the function. Graph of the function, y values all are positive. That's why the graph comes only in the first quadrant. X values also we should give only positive values of x, therefore it is only in the first quadrant. X is also positive, y is also positive, output is also positive. In output is the range, input is the set of all that is positive real numbers including 0. Input is called as domain. Now take up one more function, x square. What this function does is whenever you input some value, it will square that, it will multiply the value with itself and it produces output. That is what the this machine x square does. So I can give any real number as input, any value of x as input. It will be defined because 1 square is 1, 2 square is 4, -2 square is also 4. It is producing output. There is no real number which will not produce output. Such thing will not happen. Whereas in this case it was happening, we deleted all those negative real numbers. But here, even if you give negative, positive, 0, it always produces output. So domain of this function is set of all real numbers, and the range of this function in the sense all possible outputs. See, whatever input you give, it will produce only positive output. -1, if you give -1 whole square, that makes it positive 1. 2 -2 whole square becomes a positive 4. -3 whole square becomes positive 9. So therefore it produces only positive outputs, all non-negative reals including 0. That's why we call it as all non-negative reals. Outputs form range of that function and inputs form will domain of the function. Now look at the graph of this function to understand it in a better way. Domain means all possible real numbers can be given as inputs. Therefore entire x-axis is taken, whereas the output is nothing but the y values. Input is x values, output is y values. So look at the output graph, that is only above the origin, because above the origin contains only positive values of y. Here you won't get any part of the graph below the origin, that is it contains negative values of y. Y can never be negative here because it is a square of the given number, it is always positive. Hence you will get the graph even in the first quadrant as well as second quadrant, because entire x-axis is taken, but only above the origin, because only the positive values of y will be considered for the output. Take one more function, that is y equal to 1 by x. We have to find out domain of the function, range of the function. See, in this case, y equal to 1 by x, I can give any real number as input except 0, because if I give 0 as the input, it becomes 1 by 0, which is not defined. 1 by 0 is infinity, which is not defined. Therefore, our from the entire real numbers, I have to subtract that one particular real number, that is 0. So that is called its domain. It will work, this function will work only if I give such values as inputs. It will produce the output. Output produced also will never contain 0, because 1 by something can never be equal to 0. 0 by something is always equal to 0. As the numerator is 1, 1 by something can never be equal to 0. 1 by infinity may become 0, but infinity, it is not extended real number system, it is a normal real number system, which we can't consider. So in the range also, 0 will not be marked. Look at the graph. For 0, this particular number, there is no, because it is going towards infinity. If it is close to 0, then the graph goes towards infinity. So if it is 1, like this, see, these are the possible values. For positive values, for negative values, it will be here in this case, like minus half. Okay, for when x is equal to minus 2, when x equal to minus 1, it is minus 1. When x equal to minus 2, minus 1 by 2, that will come here. So all negative values means this portion, positive values of x means positive values of y. So this is the graph of the function. So domain means the values of x at which function is defined. Range means values of y at which it produces the outputs. Now take up one just simple problem. Examine each of the following relations given below and state in each case, giving reason, whether it is a function or not. You have to just go through the definition of function. See here in this case, r equal to 2 comma 1, 3 comma 1, 4 comma 2. Here in this case, you can do like this: 2 goes to 1, 3 goes to 1, and 4 goes to 2. Okay, there are all the elements. Actually, a and b should be given. The set a and b, you consider it as 2 3 4, and the set b as 1 comma 2. So every element of the set is having the unique association, therefore this is a function. In the second case, 2 goes to 2 and 2 goes to same 2 goes to 4. Here itself it is not satisfied, uniqueness goes, because every element should be associated with a unique element, that is not satisfied, hence it is not a function. This is not a function, this is a function. Now 1 goes to 2, 2 goes to 3, and 3 goes to 4, 4 goes to 5, 5 goes to 6, and 6 goes to 7. All the elements are having the unique association, hence this particular problem, this particular relation becomes a function. This is a function and this is a function, but this is not a function because second condition is violated. So this is how to define a function, and finding the domain of the function, range of the function, and checking whether the given relation is a function or not. I hope you understood. Thanks for watching.